Welcome back to General Chemistry mini lecture series. Today we are going to go over lecture 14, mass-mole particle relationships. We consider mole as the bridge between mass and the number of particles. So we use mole to represent a very, very big number of particles, and that big number is simply 6.022 times 10 to the third, a huge number, all right? And this actually is called the Avogadro number, and we just use Na to represent this value. Here's very important. 1 mole of anything equals 6.022 times 10 to the 23rd, that things, whatever that thing may be. That thing can be atom, that thing can be molecule, that thing can be ions, okay? So this is much more like the unit dozen. We use that here in the United States. If we say 1 dozen, we mean 12 of those individual things. So 1 dozen of eggs, there are 12 eggs. So 1 mole of eggs, actually we have this huge number of eggs, okay? We'll talk about that very soon. Okay, 1 mole of copper, of course, contains Avogadro numbers of copper atoms. And actually, this many copper atoms, or 1 mole of copper, that weighs 63.55 grams. And that is about 22 pennies made of copper, okay? So then how about 1 mole of water? Again, contains 6.022 times 10 to the 23rd water molecules. And that is actually 18.02 grams. And with the density of water at 1, so then that will be about 18 milliliters, maybe more than a tablespoon. Okay, so that's 1 mole of water. Again, I just talk about the eggs. If we really use mole to count the number of eggs, you see that will be 6.022 times 10 to the 23rd eggs. And that weighs this many grams, and that's actually 10 to the 19th ton. Obviously, mole is not the unit you should use to describe or to count the number of eggs. However, it's a very, very useful unit to work with the sub-microparticles. So now let's talk about atomic mass, molecular mass, and molar mass. Okay, so if we talk about the atomic mass, molecular mass, we use AMU. We use AMU, atomic mass unit. Okay, so however, at the MAC microscopic level, we have to use grams, and then the related unit is actually moles. So anyway, 1 AMU, that is equivalent 1/12 the mass of carbon-12 isotope. We talked about isotope in previous lectures, and that is 1.6605 times 10 to negative 24 grams. It's very, very low mass. That's why we don't want to use AMU as the mass unit when we work in the chemistry laboratory. We want to use grams. But grams, so that's related with a mole. Go back to atomic mass. Atomic mass simply is the mass of 1 atom in AMU, actually the average atomic mass as we talked about in previous lectures. You can simply find that from a copy of periodic table, all right? So the value under the symbol of the element, so that's the atomic mass. For example, oxygen, you can read that from here. The atomic mass is this many AMUs, okay? Molecular mass or formula mass for ionic compounds, they are not molecules, we just call them, so what formula actually, all right? So then that will be sum of the atomic masses of all atoms in one molecule or in one formula unit. And that's still in AMU. Take water as an example. We have 2 hydrogen times the atomic mass of hydrogen plus 1 oxygen times the atomic mass of oxygen. You add them together. This is the atomic mass, or this is the molecular mass for water molecule. So that's in AMU. And then for an ionic compound, a non-molecule substance, sodium chloride, so the formula mass, that's 1 sodium, use the sodium atomic mass, plus 1 chloride, that actually comes from chlorine, and the atomic mass for chlorine, you add those two, 58.44 AMU is the formula mass for sodium chloride. Okay, now comes the molar mass. We already used actually a molar mass in previous calculations. But now let's take another look at the definition for molar mass. That's actually the mass of 1 mole of the particles. And 1 mole means the mass of Avogadro numbers particles. Okay, let's look at molar mass of water. We know the atomic mass of water is 18.015 AMU. Then the molar mass, the value is the same. It's only in grams. Molar mass of sodium chloride, 58.44. The same value, but different unit compared with the formula mass. Okay. Okay, so let's take a look at this to further understand the concept. We have different substances or particles. So we have atoms, we have ion, that's ammonium ion, we have molecule, we have an ionic compound, all right? And then the mass of each, the mass of 1 carbon atom, 12.01 AMU, the mass for 1 ammonium ion is 18.04 AMU, the mass for 1 water molecule, 18.2 AMU, the mass for 1 NaCl formula unit is 40.08 AMU. So the mass of 1 particle for our formula unit. Then the number of particles in 1 mole, they all have the same number. Only for carbon atoms, we are talking about this many number of carbon atoms. And if it's for ion, is Avogadro numbers of that ion. Or for molecule, that's Na numbers of molecules, and so on and so forth. The last column is the mass of 1 mole of the substance or of those particles. And that happens to be the molar mass. For carbon atom or element, that's 12.01 grams. You see, the same value as the atomic mass, molecular mass, or formula mass. All right, it's the same value. So for ion, ammonium ion, 1 mole of ammonium ion weighs 18.04 grams. Now let's talk about the conversions, different types of conversions among those quantities. Make sure you understand the particles mean here atoms, molecules, ions, formula units, and so on and so forth. Okay, so as I mentioned, mole is the bridge. You can consider this as the bridge, a small bridge, all right? Use the mole concept, use the bridge of mole, we can convert from mass to particles or vice versa, all right? So there are typically 6 types of calculations here. The first 2, we are talking about conversion among mass and moles, okay? So it's this part. So number 1, from mass to mole, using the molar mass as conversion factor, okay, you know mass, all right? You start with what you know mass, grams, then doing the dimensional analysis, you are converting from gram to mole. So therefore gram, put it on bottom, that should be the molar mass, and then mole on top. That's it. We can call that method 1. Method 2 is the opposite, convert from mole to mass. Method 1 is from mass to mole, and now we want to do from mole to mass, okay? So I want you to pause here and then write the equation for that. Now, another 2 ways of on a number of particles and moles. Number of particles and moles, all right? So 2 types. One type is from particle to mole, this way, all right? From particle to mole, we can call that method 3. What do you know? You know particles. Put the particle right here, then converting from particles, that's the Na number. You use Na number as the conversion factor. And then converting to mole, put that on top. This is method 3. And then you can do the opposite calculation from mole to particles. All right? So from mole to particles. Again, I want you to write the equation for calculating from mole to particles. That will be method 4. You will use Avogadro number as a conversion factor, but you cannot use this conversion factor. You have to use the reciprocal. Now, we have two steps calculations. All of those 4 methods, they are just 1 step. But you see, in order really to use the bridge of mole, actually you can conduct 2 steps. Step 1, step 2, or step 1, step 2. 2-step conversions or dimensional analysis. Now from mass to particles. Obviously, from mass to particles, first you convert from mass to mole. That's step number 1. Then from mole to particles. All right? So therefore, you start from mass convert to mole, and then convert from mole to number of particles. Convert from mole on bottom, particle. That's 2 steps. We call that method 5. Method 6 is the opposite. Convert from number of particles to mass. So then first you need to convert from particle to moles. Convert from particle, that's what you know. N is capitalized N is the number of particles, total number of particles of your sample. Okay, converting from samples, you need to place number on the bottom, mole on top. Now, second step, we need to convert from mole to mass, therefore mole on bottom and mass on top. That's method 6. So therefore, use the 6 equations, you should be able to handle all of the conversions among mass, mole, and the number of particles. Okay, let's work on a few examples. First one, a roll of aluminum foil contains 1.375 moles of aluminum. How many grams of aluminum are in this roll of foil? First, what do we know? We know the number of moles. And what do we need to find out? We need to find out the number of grams, or the mass. Okay, we are going to do conversion from mole to mass. So we start with what we know. Okay, converting from mole to mass. How many moles? That's 1.375 moles. All right. So from mole to mass, mole on bottom and the molar mass on top. Actually, that's method 2, the one I asked you to write. So the equation I asked you to write a while ago. The molar mass for aluminum is 26.98 grams. Now you see moles are cancelled. So we should just have grams as a unit for the answer. Your calculator most likely would give you this number, but if you look at the question, the sig figs should be 4. So therefore, let me underline the last digit. So 7 is actually greater than 5. Therefore, this will be rounded up to 37.10 grams. Okay? That's for this question. Now let's look at another one. A solution sample contains 1.505 times 10 to the 23rd sodium hydroxide formula units. Calculate the moles of sodium hydroxide in this solution. Okay, what do we know? We know the number of particles. That's what we know, number of particles. And what do we need to find out? We need to find out the number of moles. So therefore, we are going to do a conversion from particle to mole. Okay? So converting from number of particles to the number of moles. And of course, the conversion factor here has to be Avogadro number. This happened to be method 3 from the previous slide. Okay? So we start with what we know, the number of particles, and then converting from particles, put that on bottom, converting to the number of moles. All right? So here, the number of moles, put that on top. Now let's replace n with the number given here, 1.505 times 10 to the 23. Then Avogadro number. So again, your calculator would give you something like this. And what's the number of sig figs in this question? That's also 4. So I underline the last digit. Then we just draw 1, the digit 1 and the 1 after that, since it's less than 5. So therefore, we have 0.2499 moles. Let's work on a couple more calculations. So this time we'll do the 2-step calculations. A 24K gold ring, that's actually pure 100% gold, that weighs 10.8 grams. So we know the mass. How many gold items are in this ring? Okay, we know mass, we need to find out the number of particles. That's 2 steps. First, we convert from mass to mole, and then from mole to particles. All right, so converting from mass to particles, but we have to do that in 2 steps, as I just mentioned. First, from mass, place molar mass on bottom, to the mole. We really need to use mole as the bridge. All right. So first we convert from mass to mole, which is the bridge, and then from mole to the particles. Okay, and the first conversion factor is molar mass. The second conversion factor is Avogadro number. This happened to be the method 5 in the previous slide we talked about a while ago. Okay, we know the mass 10.8 grams, and then the molar mass for gold is 197 grams. You see grams of gold is cancelled. Now we are converting from mole of gold, converting from, put that on bottom, then to the number. And then of course we use Avogadro number as so the conversion factor here. So therefore we place that on top. And now you see moles and moles also cancelled. All right? So now we should have a number of particles. In this case, the particle is a gold atom. So again, taking care of the sig figs, 3 sig fig, okay? So therefore, one gold ring, let's say with 10.8 grams, contains this many gold atoms. So that's a 2-step calculation. Another one. This time we know the number of particles, and now we need to find out the volume of this water sample. Volume, come on, there's no volume here. But think about it, you have to use the density of water. Okay, the volume is linked with mass. So therefore, actually first we have to convert from particles to mass. All right, and that calculation should be already 2-step. And then once we have the mass, we can use density to convert that to the volume. That's the strategy. Okay, convert from number of particles to mass, okay, which means convert from particles. Of course, you have to use the peerage of mole, convert from particles, use the peerage of mole, then find out the mass. And then you see, actually, the blue one, you are going to use method 6. Okay, that's from particle, 2 steps, to mass. Then you are not done yet, because it's a volume. It is a volume that is asked. So therefore, after we find out the mass, we have to convert that to volume. That's why I wrote that here in red. So the red part is not a part in method 6 equation. Okay, so let's do the first step first. We start with particles, converting from particles, put that on top, bottom, to mole, just like what it shows here. Number of particles, that unit is cancelled. And now from mole to mass, moles are cancelled. Okay, that's method 6. We already completed method 6 calculation, but we are not done yet. The right part, we need to convert from grams to what is asked, to what we need to find out, milliliter. So therefore, the conversion factor, we should see grams on bottom and then milliliter on top, using the density as the conversion factor. And that gives us 9.01 milliliter of water. This is actually a 3-step calculation. That's 1, that's 2, that's 3. Okay, and the first 2 are found right here. Now, end of lecture 14, quiz questions. The first one. So, how many moles of silver are in a pure silver wristband that weighs 28.5 grams? So we know the mass, and we need to find out the moles. That should be just 1-step calculation, all right? So, and we'll use molar mass as the conversion factor, okay? So we start with what we know. So we know we have 28.5 grams of silver, and then converting from grams using the molar mass is 107.92 moles of silver. And then your calculator should give you 0.26413. So that should be, of course, mole as the unit, because grams are gone. Okay. However, let's take care of the sig fig. So the sig fig in the question right here, you see 28.5, that's 3. So therefore, let me underline the third one. And obviously, the one after the last digit in the sig fig is 1. We have to drop that digit and the digits after that digit. So therefore, that should give me 0.264 mole of silver. So therefore, D is the correct answer. So now you can work on the remaining quiz questions here and many more from the homework assignments. I will see you guys in lecture 15.